Hey, my name is Desirèe García. Have you ever flipped a coin, to make a decision or something? Have you ever wondered probably of getting all heads or tails? Like when you're playing with a friend? Yeah, well, okay, so those that we get are known as random variables. Okay. Now we have two types of random variables. First we have continuous and then we have discrete. Today we're going to talk about discrete random variables. So this type is essentially a random variable that can have separate or distinct values. Tres.
Some examples of discrete random variables are how many lottery tickets you have to buy before you get the winner one, or how many courses a randomly selected student is taking. For example, hey, how many courses are you taking? 8. Yeah, well, it'll be fine.
Here we have an example of how to solve a problem with a discrete random variable. Well, here it says, in a lot of 9 computers, 3 of them have defective packaging. If an institution buys 4 from this lot, find the probability random table for the random variable X that represents the number of computers acquired by the customer with defective packaging. Well, so first here we will make our table. This X stands for the number that could have defective packaging. So here it could be 0, 1, 2, or 3. And here is the probability, which we need to find. To solve this, here is the formula. Uh, this number 6 stands for the ones that have good packaging. C is combination, that we need to use it, and 4 is the 4 that we need to have good packaging, times the 3 that is the total that have defective packaging, and 0 because here we need to know the probability of not having any defective packaging. All of this over 9, that is the total number of computers, combination 4, that is the total numbers of computers we need to buy. So we solve this, and here we got our result that is 5 over 42, and in fraction and in decimal is 0.12. All of this because of having 0 defective packaging. Well, to solve the other 1, 2, and 3, we just need to change in this place the number of 1, 2, 3 that coincide with number of defective packaging. And here we need also to change it of, if you have 1 defective packaging, of course you got 3 that have good packaging. Here 2 with good, 3 bad, and 1 that is correct. To know that this is right, you solve all the fractions and your answer must be 1. Well, here we plot our fraction that is 5 over 42, 10 over 21, 5 over 14, and 1 over 21. Well, and just to finish solving this problem, we will continue using our table and to get expected value, variance, and the standard deviation. Well, to get the expected value, we use this formula, which is just to multiply the time, the probability, the time that is of having a defective packaging times its probability, and sum them all, which we see is clearly here, and the result is 1.33. To get the variance, we will use also this formula that is having the x1, that is these ones here, minus the expected value, all of them squared times its probability. We solve them all like we see it here, and we get as a result 0.55. And just to get the standard deviation, we just get the square root of the variance, which is 0.74. And that's all of this.